Good day. Today we will be learning how to calculate gradients and intercepts and how to write the equation of a line. So first, let's review our formula to calculate gradients. Gradient or slope is equal to rise over run, which is the same as the change in y over the change in x values, and the most famous formula, y2 minus y1 over x2 minus x1. So let's do an example. Determine the gradient of the line passing through the points 4, 3, and -2, -1. So, in solving a problem like this, the first thing that you can do, which I recommend, is to draw a little sketch so you can see what your answer should be before you work it out. When we draw the sketch, we see that our line is sloping upwards. And as we should know by now, when a line is sloping upwards, it has a positive gradient. And when the line is sloping downwards, then it would have a negative gradient. If the line is horizontal, then the gradient would be equal to 0. So here, since our line is sloping upwards, we know that before we even work it out, we should get a positive answer for our gradient. So our formula is m equals y2 minus y1 over x2 minus x1. Substituting our values, we'll have 3 take away -1 divided by 4 take away -2. So 3 take away -1 will become 3 plus 1, and 4 take away -2 will become 4 plus 2. So 3 plus 1 is 4, and 4 plus 2 is 6, but we don't leave our answer for the gradient as 4 over 6. We reduce that to its lowest terms, which would be 2/3. So the gradient is 2/3. Let's review what y-intercept and x-intercept are. The y-intercept is the point where the graph crosses the y-axis. And the x-intercept is the point where the graph crosses the x-axis. So please note though that when you have the y-intercept, the x-coordinate is 0. And when you have the x-intercept, the y-coordinate is 0. That will be important later on. Let's remember that. So, let's determine the intercepts of the line that is passing through the points 4, 3, and -2, -1. So, like before, our first step should be to draw a little sketch. It's the same points as before, and when we look at it, we see that our y-intercept crosses at a number between 0 and 1. So when we do our working, we should get a number that is in between 0 and 1 for our y-intercept. So we know the gradient is 2/3. So the equation of this line will look something like y equals 2/3 x plus c. So we substitute the values 4 and 3 for x and y respectively. So y is 3 and x is 4. And then we simplify. So 4 times 2 is 8. So we have 3 is equals to 8 over 3 plus c. Simplifying as a mixed number, 3 into 8 goes 2 times with 2 remainder, so that is 2 and 2/3. Transposing the 2 and 2/3, instead of adding it, I subtract it from 3. So 3 take away 2 and 2/3 leaves me with 1/3. So the y-intercept value is 1/3. So as we expected from our sketch, we got a number between 0 and 1. Based on our sketch, it might have looked like it would have been a half, but that's why this is only a sketch, and this is the exact calculated value. So now that we know that the y-intercept value is 1/3, we can simply go ahead and write the equation of the line. It is y equals 2/3 x plus 1/3. That is how we find the y-intercept. Now, how do we determine the x-intercept? Well, looking at our sketch here, the x-intercept where it crosses the x-axis is a number between 0 and -1. From the sketch, it might look like it says -1/2. We'll see how close that is, right? That estimate. So we have the equation y equals 2/3 x plus 1/3. How do we use that to determine the x-intercept value? Well, as I had said before, remember, at the x-intercept, the y value is 0. So using that key piece of information, we can substitute 0 in place of y. Remember that whenever you have the y-intercept, the x value is 0. And whenever you have the x-intercept, then the y value is 0. So at the x-intercept, I know that y is 0, and that will be equal to 2/3 x plus 1/3. Transposing, I'll have negative 1/3. Instead of adding the 1/3, I now have 0 minus 1/3, which is negative 1/3. And then, when I look at this, dealing with fractions, both of them have the same denominator. I can just simply remove those because both sides have the same denominator, right? You can think of it as multiplying the entire equation by 3. If I multiply this side by 3, the 3's will cancel, I'm left with negative 1. If I multiply this side of the equation by 3, the 3's will cancel, I'm left with 2x. So if I have negative 1 is equal to 2x, then transposing the 2, I'll divide negative 1 by 2, and I get that x is equal to negative 1/2. So at negative 1/2 here on the x-axis is where the line crosses. There's an alternative solution for finding the y-intercept. In the previous solution, I used the point 4, 3, but I could have also used the point -2, -1. If I substitute -1 for y and -2 for x, I should still get the same answer. Let's see how that working goes. So 2 times -2 is -4. Converting -4/3 to a mixed number, I have -1 and 1/3. Transposing that, I will, instead of subtracting it, add it to the -1. So c is equal to -1 plus 1 and 1/3. That leaves you with c is equal to 1/3, just as we had gotten before. So when you solve these and you are to find the y-intercept value, you can use either the first or the second pair of coordinates. So these are some practice questions for you to work on. Calculate the gradient of the line joining the following points on the Cartesian plane, and determine the y-intercept and the x-intercept given that information. Thank you. That is all for today.